Hey, I just want to give a quick update on our map server for the robot. Um, I worked on it a little bit more and I came up with a better way of doing it than I was doing it before. Uh, Before I was using a grayscale image as the map, as like the actual map occupancy grid, and now I'm still doing that, but like internally it's an RGB image. So each each map square gets three different color channels. The idea of having multiple channels was that I can, because the issue I was having was I was using a weird decay mechanism where, uh, let me boot this up. All right. Um, so I was using a weird decay mechanism where anything in this region would decay as it moved. And what was happening as the robot was traveling, certain pixels, map pixels, would stay up underneath this brush. Say if it was turning to the left, they would stay up underneath the brush for a long time, and they would all get erased. So by having multiple color channels, what I can do is I can count the number of times a pixel is set as a lane versus the number of times that it's not. And then I can just define a function, right? So it's like each map pixel still only has one value. It's just that value is calculated based on a ratio of detections versus not detections. So it still gets thresholded all the same at this boundary, but I'm just kind of using statistics instead of just like a arbitrary decay rate. Basically, it decouples the amount of time that a pixel is up underneath this filter. So over here you have the edge detection pipeline. From color to gray, I extract them with the blue channels, and then I'll do the edge detection, and then I'll warp it to fit like this keystone shape right here. Hello? Oh well. Anyways, let me just run this thing. And so this is the actual RGB map image. I'm publishing it as like a regular video feed. And you'll see the green pixels are the pixels that's how many times the pixel's been up underneath the brush. So you see it brightens up right there. And the reason it's not this keystone shape is because it tends to roll forwards. You'll see it, this green cloud is representing how many times each map pixel has a chance to be a lane, and then the red pixels are is actually the output, because I use the blue channel to count the detection number, but it winds up working like basically if it's blue enough it turns red, so you don't see the blue. But using this method works really well. It's almost like a cloud of probability. Just kind of makes everything pop into existence, sort of. Let me get rid of these because it really slows down the. It really strains my tablet. Let me get a better picture of that. So you'll see it move. Yeah, using this method seems to be, as far as giving us the cleanest looking lines, seems to be the best bet. And so what I'm doing is I'm taking that red channel and I'm just transferring it over to a regular occupancy grid. Um, I think I'm still doing the decay. It's just at a very slow rate. But these lines are looking pretty good at this point. Um, their placement could be better. I'm still not synchronizing that freaking position vector. But overall, as far as from where I was to what I got going now, it's looking sharper. At the very least, the closer it gets to a lane, the more accurate its placement will become. And so hopefully the path founding algorithm will like avoid lanes like the devil, and it'll all kind of self-correct. It's just pretty cool looking. I just wanted to share that. All right, guys. I'll take it easy.